Alright, so we're going to take a look at an example of solving a system of equations using the substitution method. The first step in substitution is getting a variable by itself, getting any of the variables by themselves. Well, in this particular case, that step has been done for us. We notice that in the second equation, x is by itself. Therefore, we know that x is equal to 9 minus y. So the second step in substitution is taking that 9 minus y and substituting that in to the other equation. So now I have 2. I'm going to replace x in that first equation with 9 minus y. I'm going to leave my plus 3y equals 6 as it is. Now notice by doing this, in that equation I only have a y. There's only one variable. So what we're going to do is we're going to solve for that variable. So the first thing I'm going to do is use some distributive property. We're going to multiply 9 times 2, which is 18. We'll multiply 2 times a negative y, which is a negative 2y. We'll bring down the 3y equals 6. At this point, you'll notice there are some like terms that we can combine, the negative 2y and the 3y. We're going to go ahead and combine those. And a negative 2y plus 3y would give us a 1y. Of course, it's still equal to 6. Again, I'm trying to solve for y. So what I'm going to do next is go ahead and subtract 18 from both sides. So now I have y equals 6 minus 18. 6 minus 18 is a negative 12. So at this point, now I know that y is equal to a negative 12. However, I still got to find out what x is. So our third and final step is to find out what x is equal to. So we're going to take that negative 12 that we've just found, and we're going to plug it in for one of the y's. I can either put it in for this y, or I can put it in for this y. The choice is mine, whichever I think looks easier to work. In my case, I think that second equation looks like it's going to be easier to work with. So what I'm going to do is replace my y with a negative 12, and I'm going to solve for x. Of course, 9 minus a negative 12 is the same thing as 9 plus 12. And if I add 9 plus 12, 9 plus 12 equals a 21. At this point, I know both x and y. Therefore, I'm going to write my answer as an ordered pair. And that ordered pair would be 21, negative 12. Notice the x value comes first, then the y value. So the solution to our system is the ordered pair 21, negative 12. Alright, let's take a look at a second example here. Again, we're still working with systems of equations, and we're still using the substitution method. First step in substitution is to get a variable by itself. Any of the variables by itself. In my case, I'm going to take that first equation, and I'm going to get x by itself. Usually when I'm trying to decide which variable to get by itself, I'm looking for the variable that doesn't have a number in front of it, which is why I chose x. So in order to get x by itself, I'm going to need to add 2y. Therefore, x is going to equal 3 plus 2y. At this point, I've just completed step A. I got a variable by itself. The next thing I need to do is take this 3 plus 2y and substitute that into the other equation. So this time I'm using the equation 2x minus 4y equals 6. And I'm going to replace my x with 3 plus 2y, which is what I've just found. At this point, I'm going to solve for y. It's the only variable in the equation. So just like in the first example, we're going to use some distributive property. 2 times 3 is 6. 2 times 2y is 4y. Bring down the minus 4y equals 6. Now notice there are some like terms here that I can combine. I've got 4y minus 4y. And when I subtract 4y minus 4y, it leaves me with no y's. At this point, all I have is 6 on the left and 6 on the right. Now you'll notice here unlike the other equation or the other system we work with, this time there is no y in the equation. There is no variable. You'll also notice that we end up with a true statement. And when we have a true statement, we have an infinite number of solutions. So this particular system has an infinite number of solutions. Alright, we'll take a look at one more example of solving a system of equations using the substitution method. So again, the first step is to get a variable by itself, any of the variables by itself. I'm going to choose the first equation, and the variable I'm going to get by itself is the x. Again, I chose x because there is no value or number in front of that x. So I'll start by adding 2y. Therefore, x is going to equal a negative 3 plus 2y. So I've just completed the first step. Now what we're going to do is we're going to take that negative 3 plus 2y and we're going to substitute that into the other equation. This is the other equation. 2x minus 4y equals 3. What we're doing is we're taking out x and we're replacing that x with a negative 3 plus 2y. Again, this is why we call this substitution. We're taking something out and we're replacing it with something else. So now I'm going to solve for y. We're going to use some distributive property. 2 times negative 3 is negative 6. 2 times 2y is 4y. Bring down my minus 4y equals 3. Now you'll notice again, just like that second example, we've got 4y minus 4y. And when we subtract 4y minus 4y, we're left with no y's. All we're left with is the negative 6 and the positive 3. This time we have no y or x. There are no variables. But this time we have a false statement. And anytime we have a false statement, instead of having one solution or an infinite number of solutions, we have no solutions. So this system has no solutions.